Last time we have seen go back and protocol. In go back and protocol, your transmitter sends multiple frames at a time. Let us say if your sender's window is 9. For an example, let us assume that our sender's window is 9. In that scenario, it will be sending 0 to 8 frames. And then it will stop the transmission and wait for the acknowledgement. Whichever frame is received correctly at the receiver, and if it is the frame which receiver is expecting, then it will generate an acknowledgement and deliver data to the network layer, and it will wait for the next frame. 0 and 1 were delivered correctly, so acknowledgements were generated, data were sent to the upper layer, and now it is waiting for 2. If 2 is problematic, if 2 is erroneous, then when receiver receives that, it will be rejecting that. Subsequent all the frames, even though they are correct, they will be discarded because receiver cannot deliver wrong data to the upper layer. Wrong as in out of order data to the upper layer. It is supposed to give correct and in order data to the network layer. So all this frame will be discarded. At the transmitter, once you get the acknowledgement of 0, then 1, then you are waiting for the acknowledgement of 2, but there will be no acknowledgement of 2, there will be a timeout. So whenever there is a timeout in go back and sender, then starting from that frame, all the next frames will be retransmitted. This frame and the highest number frames, all of them will be retransmitted. So that is how go back and functions. Do you remember this? If our sequence number is 4 bits long in go back and protocol, then what should be the sender's window? 15, true. 2 raised to n minus 1. And what is the receiver's window in case of 5 bit sequence number? There is always 1. Receiver's window is always 1 regardless of the sender's window. Now how do we define the sender's window? Sender's window is defined as how many frames can be stored in the buffer at the transmitter. And then you will be waiting for the acknowledgement. How many frames maximum you can keep pending unacknowledged? How many frames are outstanding? That is your sender's window. And receiver's window means how many frames your receiver is open to receive at this moment. Like if it is 1, that means exactly that particular frame it will be accepting. If I say receiver's window is 2 and current sequence numbers are 2 and 3, then receiver is ready to accept 2 and 3, something like that. But so far, the two protocols which you learned, stop and wait protocol and go back and protocol, in both the protocols, receiver's window is 1. And last time we have also seen this between function. In between function, we are passing 3 variables, A, B and C. A is acknowledgement expected, which is always of the oldest frame. Whichever is the oldest frame we have sent, we generally expect acknowledgement of that. So that is acknowledgement expected. C is next frame to send. Like which is the next frame which you are going to send? That sequence number is C. And B is acknowledgement received. That what acknowledgement have you received? In go back in protocol, we deal with cumulative acknowledgement. Let us say we have sent frames 1 to 5. 1, 2, 3, 4 and 5. We have sent these 5 frames. Now, if I get an acknowledgement of 3, should I accept it or reject it? Yes, we should accept it. And what we should do when we get the acknowledgement of 3? Yes, we should stop the timer for 1, 2 and 3. Because we are getting acknowledgement of 3, we can assume that 3 is safely available at the receiver. It would be available only if 2 was also accepted. Otherwise, the receiver would not have accepted 3. And 2 was there only if 1 was there. So here we can stop timer for 1, 2 and 3. And we can clear 3 buffers 1, 2, 3 and we can send 3 more frames. That is what can be done in go backend protocol. So between function basically tells us the acknowledgement which we are receiving is that a valid acknowledgement, and we have seen example for all these three conditions as well as false. Now let us look at another function which we have. We'll be using this function whenever you want to send frame. Send data is the function. What are we passing in this function? Sequence number of the frame which you want to send, frame expected, and the buffer, which is data part of the frame which you are supposed to send. Now let us say if I want to send frame number 0, then this will be the sequence number 0. So whatever is the 0, we would write in the sequence number part. Now buffer is an array, and buffer is associated with the sequence number or the frame number, because we are keeping multiple frames outstanding. We are having buffer 0, buffer 1, buffer 2, buffer 3, because those many frames will be outstanding at a time. They will be pending together. So after sending data, we are storing them in the memory, and we are starting the timers, and we wait for acknowledgements. So now there is no single buffer, but buffer associated with the sequence number. Now let us say if I'm expecting frame number 4, frame number 4 in go backend protocol, then up to which frame I would have received? Up to frame 3 we would have received. So if I'm expecting frame number 4, is it okay to send an acknowledgement of 3? If we are waiting for frame number 4, if frame expected is 4, is it okay to send an acknowledgement of 3? Why not? Why not? Tell me. That is okay. It is already acknowledged. Or rather, let us say we are generating an acknowledgement. Currently, we are building a frame and we are generating an acknowledgement. Or let us say we might have already sent one acknowledgement of that. But what are we doing here? We are following the frame structure. So when we are following the frame structure, we will always be sending sequence number, acknowledgement number, and then data. So if I want to send some frame, then sequence number, whichever we have to send, that we will be writing in the sequence, of course. Then what should I write in the acknowledgement number? If other party has not delivered anything right now, but I have to follow the frame structure, I'm waiting for frame number 4 and I'm sending, let us say, 15th frame. So in the first field, I'll be writing 15. In the acknowledgement field, what should I write? No, not 4, 3. Because you are waiting for frame number 4. You are waiting for frame number 4. So you cannot acknowledge 4. That you have not received. But you have received up to 3. So you can send an acknowledgement of 3. Everyone, are you with me? There is no harm in sending acknowledgement of k minus 1 if you are waiting for k frame. Does it make any sense to you? Everyone, if you are waiting for frame k, you can always send an acknowledgement of k minus 1. Yes or no? When you send k minus 1, then no, exactly k minus 1, because latest acknowledgement you should be sending. Why should you talk about the past, recent past? Let us talk about that. And k minus 1 covers k minus 2. K minus 1 covers k minus 3. Let us say if your receiver is waiting for frame number 6. Everyone please pay attention. In go backend protocol, your receiver is having variable frame expected 6. What is meaning of that? It would have received frame number 5. It would have generated acknowledgement of that, and it would have delivered this frame to the upper layer. Then only it will be waiting for frame number 6. So at any point of time, there will be no damage in delivering acknowledgement of 5. if you are waiting for frame number 6. Do you understand this? Okay. So now let us look here again. In the send data, we are passing on 3 variables. One, sequence number, which frame we are expecting, and the data. Now, information part is the data. So initially we are having, let us say, A0. So whatever is in A0, that we are writing in the information part. Packet which you got from the network layer, that we are writing in the data part of the frame. Frame number is the sequence number. Frame expected, if it is 4. What is the maximum sequence number? Here we are defining maximum sequence number as 7. See, remember this. For this protocol, maximum sequence number is 7. So 4 plus 7, 11. Modulo operation 8. 11 modulo operation 8. What will you get? 3. That means it will generate acknowledgement of 3, and that is fine with us because we are waiting for frame number 4. So I should send acknowledgement of 3. If I am expecting 0th frame, then 0 plus 7 modulo operation 8. Then 7 acknowledgement will be sent. And we know that we are using the sequence numbers here. So that is fine. If you are waiting for 0, then you should send an acknowledgement of 7. And now our frame is constructed, which is having 3 fields: sequence number, acknowledgement number, and the data. We can send that to the physical layer, and we are starting the timer. So whenever you have data to send, then you can directly call this function send data. This function is constructing a frame, sending to the physical layer, and starting the timer. We are not going to discuss this function anymore afterwards. We will be directly using that. Is it okay? Feel free to ask me if you have any doubts in this function. Between function tells you whether the acknowledgement which you have received is a valid acknowledgement. Send data function constructs a frame for us. It gives to the physical layer and starts a timer. So everyone, now take a deep breath. We are going to start the actual program of stop and wait. If you be with me, in a focused way for 10 minutes, we'll be done with the program. So let us start. So this is the program. In this program, we are having a sender and receiver. They are of the trans receiver. Sender is the transmitter and it is receiver also at other point of time. There is no concept of having pure transmitter and pure receiver. Both the parties, all the host, they are going to act as transmitter and receiver at other point of time. They are going to be trans receivers. So we have variables: next frame to send, acknowledgement expected, and frame expected. Can you please tell me whether next frame to send is a variable of transmitter or receiver? Here all the parties are trans receiver. But when it is acting as a transmitter or receiver, then which point of time next frame to send is going to be used? Transmitter. Yes. Acknowledgement expected, is that a variable of transmitter or receiver? Transmitter. True. And what about frame expected? Frame expected, is it at the transmitter end or receiver end? Receiver end. True. That is true. And now we are having buffer maximum sequence number plus 1. We are having buffer of 8. We are defining 8 buffer here. Why? Because the sequence number is 3 bits long. So our range will be 0 to 7. So I can have buffer 0, buffer 1, buffer 2, buffer 3, buffer 4, buffer 5, buffer 6, buffer 7. That is why we are going for this range of the buffers. Now in buffered is a variable which tells us that how many frames are buffered. And buffered is a variable which lets us know that how many frames are buffered at the moment. Buffered as in we have generated those frames, we have sent them, and now they are stored in the buffer. Until what point of time? Until we get an acknowledgement back. Once we get an acknowledgement back, we can clear that and next frame can be sent. So n buffered gives us idea that how many frames are outstanding at any point of time. And now we are no more assuming that network layer is always ready. So far we have assumed that network layer is always ready and network layer always has data. So whenever we wanted to read, we have directly executed from network layer. Now our event is network layer ready as well. So we are assuming that network layer may have data at some point of time. It might not have data. So we can perform from network layer function only if network layer is ready. In the similar fashion, if you don't want data from the network layer, you can disable network layer. So now all the layers work independently, and depending on your requirement, you can enable or disable network layer. So initially we are enabling network layer because we have just begun and we are ready to send data. We are enabling network layer. Acknowledgement expected is 0. Next frame to send is 0. Frame expected is 0 and n buffered is 0 because no frame has been sent so far. And now we are waiting for an event. What do we do now? We wait for an event now. So can anyone tell me which are the possible events at this point of time? We have just begun. We have not sent anything so far. So which are the possible events at this point of time? Say, look at the possible events. You have booted your system, initialized variables, and you have enabled network layer. That is what we have done so far. So which of these 4 events do you think may take place? Yes, network layer ready can take place because if network layer is ready, you can have an event network layer ready. Similarly, Abhi, you are also right. It can also be frame arrival because if other party has sent you data, it can be frame arrival. Then if the frame is correct, the data is intact, then it will be frame arrival. But if the frame is garbled, whatever data was sent that is corrupted, then what event will we have? Yes, then we will have checksum error. Can we have timeout at this point of time? No. So timeout is not possible because we have not started a timer. You can have frame arrival if the frame is correctly coming. You can have checksum error if frame is problematic. You can have network layer ready. Okay. So currently we are assuming that other party has not sent us anything. The other party has not sent us anything and we are waiting for an event. Then which event is likely to happen? We have begun and no one has sent us any data so far. Just to make things simple at this moment, we are assuming that. Then which is the possible event? No one has sent us data so far. Keval, I am saying that. So how can we have frame arrival? We have just begun. We have not sent anyone anything. Similarly, no one has sent us anything so far. Yes, network layer ready. Then the only possible event is network layer ready. And this we are assuming for our convenience. So now let us say in the normal scenario, we will have network layer ready. That means network layer has data. So what should we do? Read data from the network layer in buffer 0. Next one to send is 0. So in buffer 0, I have read data. Let us say A0 data I have read here. Just a second. Okay. So from network layer, we have read data in buffer A0. Then n buffered is incremented by 1. Why? Because now we have stored one frame. So buffer n buffered is incremented by 1. एक second. Okay. So n buffered is now 1 because we have stored that frame. Then we are using send data. In the send data, next frame to send is 0, frame expected is 0, and buffer is a 0. So can you tell me what frame will be constructed here? We are sending 0, 0, a 0. So what frame is constructed? 0. In the frame we have three fields: sequence number, acknowledgement number, and data. So what frame would be constructed? Come on, this is a no-brainer. 0, 7 is 0, isn't it? Because this is obvious. 0, 7, A0 will be constructed because all these variables are 0. So we are sending 0, 0, A0. So A0 is written in the information part, sequence number is 0, and 0 plus 7. 7 modulo operation 8. So 7. 0, 7, A0 frame will be constructed. How many of you understand that 0, 7, A0 would be constructed? Because this 0 is the frame expected. Which frame are we expecting? 0. 0 plus 7 modulo operation 8. So 7. And even if you not try to correlate like that, in stop and wait protocol, in the first frame, what acknowledgement number were we sending? We were sending 0, 1. Because the other party was expecting 0, so you were sending 1. Here the other party is expecting anything from 0 to 6. Because the range is of 7 to raise to n minus 1. So it is expecting anything from 0 to 6. So it makes sense only to send 7. So by that logic also we should be sending 7. Yes? Okay. So I hope that you are with me. Network layer enabled, network layer ready event was there. So we have read from the network layer in the buffer 1 data. We have incremented n buffered by 1. We have constructed a frame, sent it to the physical layer, and we have started a timer. Now increment next frame to send. So can we quickly revise what variable values are right now? Acknowledgement expected. What is acknowledgement expected after executing this one? Once we have executed this, what is the value of acknowledgement expected? That is still 0. Yes. What is next frame to send? Next frame to send is 1. Yes. And what is this frame expected? What is the value of frame expected? 0. Yes. That is 0. And what is n buffered value? 1. True. So next frame to send is 1. N buffered is 1. Acknowledgement expected is 0. And frame expected is 0. Now break. So see, where are we coming in this while loop after break? Break means coming here. If n buffered is less than maximum sequence number, then enable network layer. Else disable network layer. So n buffered is 1. 1 is less than 7. So enable network layer. So again we are waiting for an event. Now this time also let us say event is network layer ready. So what do? In buffer 1 we are getting next data, that is A1. N buffered value is now 2. We are constructing next frame 1, 7 and A1. That is what we are constructing 1, 7, A1. And now next frame to send is 2. Again we are checking here, value of n buffered is 2, which is still less than 7. So enable network layer, otherwise disable network layer. So again we are coming here, network layer will be ready. So in the normal condition, if your network layer is having sufficient data, tell me how many times network layer ready event we are going to execute? Seven times, not 8 times, because see, maximum sequence number is defined as 7. So whenever it is 7, whenever n buffered value is 7, then 7 is not less than 7. So it will be false and we are going to disable the network layer. So when we disable the network layer, that means we are informing the network layer that we are disabling you. So network layer will no more give you network layer ready event. So maximum 7 frames you will be able to keep outstanding. And that also makes sense because we wanted to send 2 raised to n minus 1. Do you remember that? The sender's window is 2 raised to n minus 1. We never want to send more than 7 frames. So this works just perfectly. So please tell me how many of you understood this function, network layer ready, and this part, that n buffer is helping us to know how many frames are outstanding. So the moment we have kept 7 frames outstanding, we are going to disable the network layer. So kindly let me know if you understood network layer ready function. This particular case, have you understood this? Keval and Love, two have understood that. And Abhi, Rikin, okay fine. So I think that you are getting that. So now let us think of the transmitter situation and very quickly revise the variable names. What is the acknowledgement expected value at this point of time? No, it is 7, it is 0. We have not changed acknowledgement expected at any point of time. We have sent 0 to 6 frames. 0, 1, 2, 3, 4, 5, 6. Those many frames we have sent. We have sent those many frames. So your acknowledgement expected is still 0. In the normal scenario, we are still expecting acknowledgement of 0 only because that is the oldest frame. This is the first frame which we have sent. So of course we are going to expect acknowledgement of that. So acknowledgement expected is 0. Just focus on these variables which we have incremented. What is the next frame to send? Next frame to send is 7. Everyone, please. We have executed this 7 times. We have incremented next frame to send here. Come on. Yes, again, that is 7. And what is frame expected? The value of frame expected after executing this 7 times? 0. Yes, that is 0. And what's n buffered? 7. True. So we have sent 7 frames. So n buffered is 7. Next frame to send is 7. And acknowledgement expected and frame expected is still 0. Okay. So now we have stopped in disabled network layer. So which are the possible events now? Now again we are waiting event here. Which are possible events? Yes, either you can have frame arrival or you can have timeout. Because you started timer also, so either you can have timeout or you can have frame arrival. So we are going for the normal course of actions where we are assuming that everything went well and data was delivered properly. So we have frame arrival event. If it is frame arrival, we are going to read frame from the physical layer. And what shall we do? We should is sequence number same as what we are expecting? Sequence number, if it is same as what we are expecting, that means initially we are expecting 0th frame and we are getting 0th frame. Then put information part of that which is packet to the network layer and expect the next frame. That means increment frame expected. Whenever you are getting correct frame in sequence, then we are delivering data to the network layer and we are expecting the next frame. That is what we will do. We will also check, is sequence number, is the acknowledgement number okay? So acknowledgement number is 0. If you are getting 0 and next frame is 7. So this between function as we have seen in the last class will return true. If while is true, then n buffered, here it is minus. N buffered is reduced by 1 because 1 frame has left the network now. we have got an acknowledgement. We have got an acknowledgement, that means receiver has generated that. Receiver would generate it only if it has correctly received that. And if receiver has correctly received that, our job is over. We don't need to buffer it anymore. So n buffered will be reduced by 1 and we are stopping timer for 0. And now increment acknowledgement expected. Now expect the next frame, next acknowledgement. Expect the next acknowledgement. That means now we are expecting acknowledgement of 1. So again I repeat, whenever we receive a frame, there are two parts in the frame, data part and the acknowledgement part. So data part is put to the network layer if it is the frame which we are expecting, and then we expect the next frame. If the sequence number is what we are expecting, then put on data to the network layer and expect the next frame. If the acknowledgement is correct, if it is a valid acknowledgement, then stop the timer, clear the buffer and expect the next acknowledgement. Now let us say, okay, first let me ask you, is this clear? Whenever frame arrives, this is what we do. We read the frame, we check the sequence number. If sequence number is what we are expecting, then we deliver data to the network layer and next frame is expected then. Then we check the acknowledgement part. If acknowledgement is what is valid, then we are going to reduce n buffered by 1 and we are going to stop the timer and we are going to expect the next acknowledgement. Is this okay with you? Rikin? Yes. Okay, fine. So tell me, if we get an incorrect frame, then we are going to have which event? Checksum error, yes. And if it is checksum error, what are we supposed to do? If you checksum error, that means bad frame has come to us. No, ignore that. Like checksum error is from the receiver's perspective or transmitter's perspective. As such, we are trans-receiver. So all the parties are going to act as transmitter at some point of time and receiver at other point of time. But checksum error will take place when the frame has arrived. That means you are acting as a receiver at this point of time. And you have received a bad frame, an incorrect frame. Then what are we supposed to do? Ignore it. Discard it, yes. Ignore it, discard it. So if the case is checksum error, simply break. Don't read it. Don't even bother to read that frame because that is incorrect. Discard it. So after some time, there will be a timeout at the other party because we have not generated acknowledgement and that party will be retransmitting that. So let us again look at this point, okay, that we have sent frames. Then when the event is frame arrival, we read the frame. If the data is correct, we do the needful. If the acknowledgement is okay, we stop timers and we reduce n buffers and we expect the next acknowledgement. Now let us say next frame to send was 7. Initially we have sent 0 to 6 frames. That means 7 frames we have sent. So next frame to send was 7 and acknowledgement expected was 0. So if there is a case of timeout, then what is smartly done here is acknowledgement expected is given to the next frame to send. Your next frame to send is assigned the value of acknowledgement expected. That means whatever is the oldest frame, that acknowledgement you are going to expect. If you send 3, 4, 5, then acknowledgement expected will be 3. Whenever there is a timeout, then of course it would be timeout of 3 only, not of 4. Because 4th timer was started after 3. When I'm sending 3, then I'm sending 3, I'm starting a timer. I'm sending 4, I'm starting a timer. Then we send 5 and we start a timer. So now whenever timer goes off, that means the timer is always of the oldest frame. So, and that is the frame of which acknowledgement we were expecting. So that acknowledgement expected 3, we are putting in the next frame to send. Be with me. 3, 4 and 5, this 3 frames we have sent. Next frame to send we are initializing with 3. And your n buffered value would be 3 also, because we have sent 3 frames, 3, 4, 5. So now I is 1, 1 is less than 3. So send 0th frame. Increment next frame to send. So it will be 1. Send next frame and send next frame. So 3 frames will be retransmitted. So in timeout function, we are reinitializing our next frame to send with the oldest frame which is outstanding, which acknowledgement we were expecting. And starting from there, we are attempting retransmissions of how many frames? Of all the frames which are buffered. And that we are tracking by n buffered value. So not only just one frame is retransmitted, but all the frames which we have stored one by one, they will be retransmitted. Have you understood this? Is the timeout function clear? If not, please ask me where you have any doubt. Which part of this you don't understand, please let me know. We are making use of n buffered at 2 point of time scale. One, to know that whenever it has reached 7, that means now we should disable network layer. That is first scenario where we are using n buffered. N buffered gives us the limit that up to which how many frames should be outstanding. So once n buffered is same as maximum sequence number, our buffer is full and we are disabling network layer. That is one use of that. Another use of that is here. Like as you have pointed out, in the timeout, n buffered is telling us how many frames are outstanding. And those many frames we are supposed to retransmit. In go back n, if you sent 1 to 15, you have got acknowledgement of 1, then 2 to 15 are outstanding. If you got acknowledgement of 2, then 3 to 15 are outstanding. Now, if we have timeout for 3, then starting from 3 to 15, all the frames are supposed to be retransmitted. So that how many frames, that idea we are getting by n buffered. Others? See, in the stop and wait, whenever there was a timeout, because only one frame was outstanding, you were sending that one frame. While here, we are sending all the frames which are unacknowledged. Because we know. Why do we do that? Because your receiver is having just one frame worth buffer. Receiver is accepting data in order and correctly. So if it has missed 3 number, then even if 4th is correctly reaching the receiver, it is going to discard that. It will discard 5, it will discard 6. It cannot accept them. Because if it does, then it will have to deliver them to the upper layer. Then only it will be able to accept the next frame. And that would be delivering out of order data to the network layer. And then we are not being reliable if we do that. So are we on the same page? So that's it. Okay. So very briefly, let me repeat. If the event is network layer ready, read from the network layer, increment n buffered, construct a frame, send it. If it is frame arrival, if sequence number is okay, then put that to the network layer, expect the next frame. If acknowledgement is okay, stop the timer, n buffered is reduced by 1 and expect the next acknowledgement. If it is checksum error, don't do anything. If it is timeout, then all the pending frames, all the unacknowledged frames are to be retransmitted starting from the oldest frame. And if you have sent lesser data than 7, then enable network layer, and whenever network layer has data, send it. Once you have reached the limit, then disable network layer. So that is crux of the go backend protocol. It might seem a little bit difficult to you at the moment, but I would recommend you to take example and then see how it functions. then I'm sure you will be able to correlate that with the theory and you will be able to appreciate how nicely this code is written. So again, feel free to ask me if you have any doubts in this. Any girl, would you like to ask me any doubts if you have? Or let me know if you understood this. There are around 40 students here and I'm getting response from 6 to 7 students. So others, either you are being too lazy to write it or you have not understood that or I don't know what the case is. So let me know if you are struggling anywhere. I'll repeat it. So should I assume that all of you understood go back in protocol and go ahead with the next protocol? Okay, channel, let us do that. So we have seen stop and wait protocol where your sender's window was 1, receiver's window was 1. Then we have seen the next version, next protocol, go back in protocol, in which your sender's window is depending on the sequence number length. Multiple frames are unacknowledged from the sender's side. Receiver's window is 1. So efficiency will be better than stop and wait. But still efficiency is not very high because even if one frame is incorrect, we end up retransmitting so many frames. Receiver, even if it is getting correct frame, but if it is out of order, due to limitation of buffers, it is unable to store them. And hence the burden is on the transmitter and communication links to carry the retransmissions and it is not very efficient. So can you suggest me any remedy that how can we improve this? Can you think of anything which will help us improve the efficiency? That what should we do in the go back end so that we may end up with the better protocol? Yes, Kaval, please.
Hello, ma'am. Am I audible?
Yes, yes.
Yes, ma'am. In this case, let's say we are getting error in the sending the frame 3, then we are sending all the frames once again. But what we can do is, let's say we need to send the frame number 0 to 7, and let's say error is occurred at the frame number 3. Then we should not send all the frames again. We keep that frame not sent and send the next frame. And whenever the time occur, or we can say in between, we can send this frame that is not correctly sent.
But see, why are we doing that, Keval? We are sending all the frames whenever there is a timeout because we know that receiver is not capable of accepting out of order frames. Like if 3 was dropped, then even if 4 was correct, is receiver of go back in protocol accepting that?
No, ma'am.
No, that is why we are doing that. So at the transmitter, what you are saying is true, that rather than sending all the frames, if we could, just repeat the frames which were problematic, that might be helpful. But we can do that only if your receiver cooperates. So what changes would you recommend at the receiver?
Ma'am, we also need to send some one extra thing to tell the receiver that okay, this frame is not you getting. Okay, we will send this frame next.
Mm-mm. Then what? I mean, you tell the receiver, but receiver has just one buffer. So receiver can accept the frame, and if it wants to accept the next frame, it will have to deliver empty the buffer. That means it will have to give the data at somewhere. So it will have to give that to the upper layer. Yes, Sahil, that is true. What Sahil is suggesting is you have to increase the window size of the receiver. If your receiver can store some frame momentarily at the data link layer, in this case, we will be having no burden at transmitter to retransmit all the frames, because receiver is having those frames stored temporarily somewhere. So if we have multiple buffers at the receiver and transmitter, then probably we can reduce number of retransmissions. Here we are retransmitting because your receiver has to accept it or reject it. These are the only two options. And if it accepts, then it will have to give to the network layer. Rather than that, if I'm saying that receiver is having sufficiently large window that it can store some frames there whenever they are out of order, then probably it might help. And that is what we precisely do in the next protocol. So everyone, this is protocol which is actually used in the real life. So please be with me. And the size would be same. If your transmitter has 4 buffers, your receiver will also have 4 buffers. So let's say we are using 2-bit sequence number. Feel free to ask me whenever you have any doubts, but try to be with me for a few minutes. When I say I have 2-bit sequence number, I know that the sequence number range is 00011011. So the sequence numbers are basically 0, 1, 2, and 3. These are the sequence numbers which we have. So now, if your receiver is having 4 buffers, in this scenario, let us assume that receiver and transmitter, they have 4 buffers. That means your transmitter is sending 0th frame, 1, 2, and 3. Now it will stop. Your transmitter sends 0, 1, 2, and 3, and then it is stopping. Let us say receiver receives give me a moment. If receiver receives this frame correctly, what should receiver do? Give data to the network layer, send acknowledgement of that, and now wait for sequence number 1. Now let us say 1 is also correctly delivered. Then what will your receiver do? Receiver will read this frame, it will give data to the network layer, corresponding acknowledgement is sent, and now it is waiting for the next frame, which is frame number 2. Transmitter has already sent 0, 1, 2, and 3. Now let us say this is not reaching in the proper manner. Data is changed. Checksum failed. Then can you tell me what should your receiver do? Should it give this data to the network layer? No, it should not. Should it generate an acknowledgement? No, it should not. Now let us say, so it will discard the data. Discard the frame. Just throw it away. Don't do anything. Now this frame is correctly received. Your receiver is receiving this correctly. Then what should receiver do? Should it give to the network layer? Should it pass on this data to the network layer? No, it should not. Why? Because we are supposed to pass data in order to the network layer. So we have sent 0, 1, but you have not sent 2. So 3 you should not give to the network layer. You cannot give to the network layer. Can you generate an acknowledgement of this? No, you cannot generate an acknowledgement because we are dealing with cumulative acknowledgement. So the moment you say that 3 is received, your transmitter will assume that 3, 2, 1 and 0, everything is received. So you cannot generate an acknowledgement. You cannot write data to the upper layer. However, you don't need to discard the frame. Store this frame at the data link layer. Yes. In the buffer of 3, we have this buffer. We have 4 frame worth buffer available at the receiver. So in this buffer, we are storing this frame at the moment. So what will happen at the transmitters now? Tell me. You have sent from the transmitter 0, 1, 2, 3 frames. At the receiver, 0 and 1 were correctly received. We have delivered data to the network layer. Corresponding acknowledgements were generated. 3 was in third frame, which is frame number 2 was incorrect. We have discarded it. Third was correct. So we have not delivered that to the network layer. We have stored this frame at the data link layer itself. And we have not generated any acknowledgement. So which events do you think will take place at the transmitter? No. Let us go a bit slow. What will happen at the transmitter? No. Still in sequence, what will happen at the transmitter? What you are saying will take place, but after some time. Before that, something else will happen. You will get an acknowledgement of 0, isn't it? You have sent 0, 1, 2, 3. So you will get an acknowledgement of 0. So when we get an acknowledgement of 0, we are going to stop timer for 0. And if you have data, you can send the next frame. That is 0th frame, and that is actually the 5th frame. Then you will receive an acknowledgement of 1. When you receive an acknowledgement of 1, you will stop timer for 1, and next frame can be sent if transmitter has data on hand. After that, what you are saying will take place. We will have a timeout for 2. Now we will have a timeout for 2. That means retransmit frame number 2, which is the third frame. This frame will be retransmitted. Now this frame will receive at the receiver. So what will receiver do? Receiver will check that okay, 2 buffer is empty. So it will be receiving this frame. It will store it. And what will receiver do now? Please tell me. First receiver received incorrect frame, which was 2. So it has discarded that. Now this time, this frame number 2, let us say, that is correctly received. This time it is correctly delivered at the receiver. So what should receiver do? Yes, send to the network layer. Which frame? Send frames 2 and 3 to the network layer. Because now they are in order. It could not give 3 out of order to the network layer, but now there is no gap. The gap is filled. So 2 and 3, both of them will be sent to the network layer. And which acknowledgement can be sent? Yes, you generate the acknowledgement of 3. Well done. Acknowledgement of 3 can be sent. And now we wait for the next one. Now see, this depends on the implementation. If your receiver wants to send acknowledgement of 2 and 3 separately, that is also fine. But most of the smart operating system nowadays, they will be sending the latest acknowledgement because that will be covering the earlier acknowledgement anyway. So it will be sending acknowledgement of 3. So if I try to summarize this in 3 lines, I can say at the receiver, if data is correct and in order, then send data to the network layer, generate the acknowledgement. If data is correct but out of order, then do not generate the acknowledgement, do not deliver data to the network layer, hold it temporarily at the data link layer itself. If the data is incorrect, discard it. These are the rules at the receiver. What are the rules at the transmitter? Send the frames. Whichever timer goes off, only that one is to be retransmitted. So here, whenever there was a timeout of 2, we have retransmitted only 2 and not 3 in subsequent frames. So selectively, we are repeating only those frames which are having problem, which are corrupted. And that is why efficiency will be better than go back and protocol, but at the cost of managing the complex operations at the receiver and memory. But I think we understand that memory is not an issue now. Memory is not so expensive or difficult that we cannot have memory. To improve the efficiency, of course, we can have decent amount of memory available at the transmitter and receiver, and we can afford to have selective repeat protocol. This is the protocol which is used actually in real life. Do we have any questions? Others? Can I please have different names now? Okay, thank you, Harsh. So, we have seen many programs pseudocode rather. In the class, first we have seen pseudocode where there was no error, no delay, infinite processing power. The second step was when there was some finite delay in the stop and wait scenario. The third was noisy channel, and then the realistic program of the transmitter and receiver. The fourth was when bidirectional communication was taking place, then how they'll be acting, that we have seen using piggybacking. Then the fifth was go back in protocol, which we have seen today. And I expect you to go through program of selective repeat. Please, allocate around 1 hour to that and try to go through program of selective repeat. There is just one program. The same program will be effective at the transmitter and receiver. And that program also uses between function, which we have seen in the stop and wait protocol. Between function is used in the selective repeat as well, because here also we deal with cumulative acknowledgement. So try to go through this selective acknowledgement. In this session, I have given you just 2 assignments to you. The first one is to do parity by Hamming distance on your own. That was the first topic. And the second topic is this one. Selective repeat, I have explained you the concept, but I want you to map that with the pseudocode. Will you do it? You better do it. I'm going to ask you in the examination from that. Okay. So if you have any doubts, feel free to ask me. Yes, they are in the textbook. These programs are there in the textbook. So go through them, assign values, dry run them in the book, and if you have any doubt, you can discuss first among yourselves, and then of course you can approach me at any point of time. But you cannot just tell me that explain the entire program. You have to show me that you have put in efforts, like you have done this and this part you are not understanding, something like that. Data link layer and introduction, that is what we have covered. And in the other portion, I think physical layer and some part of the network layer, I'm not very sure. That is what we have covered. So if you don't have any doubts, we can stop it. If you have any doubt, please ask me. Okay then, all the best. I'm ending the meeting now.